Um, Good morning, everybody, and welcome to our pre-calculus class. Today, what we're going to do is we're going to continue on our lesson one. We started the trigonometry yesterday. And we didn't get very far, and I didn't really want to do a long lesson yesterday because I know some of you are still writing the test. So, yeah, like I said, we're going to continue on today. It's going to be a longer lesson today. So you can um, please bear with me and we'll get through this. So yesterday we talked about angles and doing the angles in a standard position. So today what we're going to do is we're going to continue on and talk about reference angles. So reference angles, what does that mean? And this is something that's going to be super important. So we need to know this one. Okay, so let's see what reference angles look like. For an angle in standard position, okay, so we already know what angle in standard position is. So we said angle in standard position is that the vertex starts at 0, 0, and the initial arm is right on the positive x-axis. So that's what we talked about yesterday. Standard position, vertex, vertex at 0, 0, and initial arm is on positive x-axis. Okay, so that's from yesterday's lesson. Now, the acute angle less than the angle between the terminal arm and the x-axis is called a reference angle. So, a reference angle. Now, it's probably better to draw that out. Okay, so a reference angle is the angle between the terminal arm. Terminal is where the arm stops and the x-axis. So any angle that is greater than 90 has a corresponding reference angle. So this means that reference angle denoted by theta r are always positive and less than 90 degrees. So let's put like a star beside it, because that's going to be super important. So theta r, reference angle, okay, is always positive and it's always less than 90 degrees. So let's do that. Okay, so to do that here, determine the reference angle for the following angles. Let's see where 95 degrees is on our graph. Okay, so I'll just have to draw it out because sometimes it's better when we see a picture. Okay, so let's say this is our Cartesian plane. This is going to be the 0. Now, because this is a positive angle, so that means we're going to turn around this way in a counterclock motion, 95 degrees. So this is 0 degrees, and then this is 90 degrees. 95 would be slightly over 90 degrees. So 95 degrees is here. Okay, so this is initial arm, and then the vertex is right at the 0, 0, and then it rotates this way counterclockwise 95 degrees. So theta, I'm going to call that as 95 degrees. Now, what we're trying to do is not to figure out what the angle in standard position. What we're trying to do is to figure out the reference angle. Okay, what's the reference angle again? The reference angle is the angle between the terminal arm, so this is the terminal arm, and the x-axis. Notice that they said x-axis, not positive x-axis. As long as it's between the terminal arm and the x-axis. So x-axis is right here. So here is our theta r. Okay, I know it says there up lowercase, but sometimes I like uppercase r. Doesn't really matter. So theta r is this angle over here. Okay, so how big is that angle theta r? How big is theta r? Well, let's see. So from here to here is 180 degrees. And then if we take away the 95, theta r is equals to 180 degrees minus 95 degrees. So theta r is equals to 85 degrees. So that's this little angle right there. Okay, so theta r is from the terminal arm in between terminal arm and the x-axis. Okay. Okay, so if you're not quite sure about that one, let's go on and move to the next one. Let's see what that looks like first. 227 degrees. So that means our angle is a positive angle. So that means it's going to rotate counterclockwise. Counterclockwise. Okay. So this is 0. This is 90. This is 180. And then this is 270. And if I go all the way around, we're back to 360 at this particular arm. So I'm going to start my initial arm here. This is my initial arm. Initial arm. And then I'm going to rotate that arm for 227 degrees. So if I rotate that arm to a 227 degrees, I'm going to land somewhere right over here. Okay, initial arm, terminal arm, and it's rotating this way. Okay, so theta is equals to 227 degrees. Okay, I'll bring it a little bit closer, probably a bit easier for you. Now, what we're going to do? Well, where is theta r? Reference angle. Okay, I'm just going to grab a pen so you can see it better. Theta r is the angle between the terminal arm and the x-axis. So this is theta r. Theta r. So how big is theta r? Okay, so if I want 227 degrees, and if I subtract by 180, then I'm going to be left with this little angle right there. So theta r is equals to 227 degrees minus 180 degrees. Okay, so 227 minus 180, and it's going to give us a 47 degrees, 47 degree angle right there. Okay, maybe I should do the same thing in here so you can see it's theta r. Okay, there you go. Good. Okay, so we've done 2 examples. Now we're going to go to the third example in here. This one is a negative angle. So negative angle, so that means we're going to turn clockwise. Okay, so we're going to rotate clockwise. Let's do that right here. We didn't give you a lot of room in here. That's okay. Now, because it's negative degrees and we're going to turn clockwise, so turning it from here, okay? So this is still our initial arm, right? The vertex is at 0, 0 onto the positive, along the positive x-axis. And then if this is 0, then that means this is going to be negative 90 degrees. This is negative 180 degrees, and then negative 270 up there. So where is negative 38? Negative 38 would be right there. Right there. So theta equals to negative 38 degrees. Now how big is the how big is the theta r? Theta r, okay, so theta r is equal to, you look at this one here, how big is the angle between the terminal arm and then the x-axis? It's going to be also 38 degrees. 38 degrees. Okay. So theta is negative 38, but then theta r, reference angle, is positive 38. Remember, it's always positive. Right now, there's no reason for that right yet, but we'll figure that out and as we go on. Okay, so let's take a look at this one. 655 degrees. Okay, so this is a positive angle. And we're gonna go counterclockwise. We're gonna go counterclockwise. So go here. Where is 655 degrees? Well, if we go all the way around once, that's gonna take us up to going around 360 degrees. But then this is 655, so that means we've turned around more than one full turn. Okay, so let's see here. And this is how I showed it yesterday. I went 655 divided by 360. So that's 655 divided by 360 is going to give us 1. Then minus 360, that's going to give us 5. That's going to give us 15 minus 6 is 9. So this is going to be 5,295. So that means that means we've circled around one full round, and then we have to continue on for another 295 degrees. Well, how far is 295 degrees? Again, 0, 90, 180, 270, and then this is another 3. Go 360. So we're going to go around. I'm going to go this way. So it will take us to quadrant 4. Take us to quadrant 4. Okay, so if this all the way around takes us to 295 degrees, how big is the reference angle? So the reference angle is from terminal arm. This is the terminal arm, and then this is the x-axis. So this is theta r. So theta r is equals to 360. Let's go theta r. If we go 360 minus 270, that's going to be theta r is equal to Oh, sorry, that's not 295. 295. So that's going to give us 65 degrees. So this part here, theta r, is 65 degrees. Okay, last one. This one's really tiny. I can't see that one. Too small. Okay, so this one, because it's a negative angle, we're going to go clockwise. Turn clockwise. I'll just go this way so we can see it better. Okay. I know some of you are watching on your phone. So where is negative 263? So this is 0. This is going to be negative 90, negative 180, negative 270. So where is negative 263? Our initial arm is right here on the positive x-axis. And then we're going to turn around all the way to here. So that's quadrant number 3. Okay, so turning around this way because it's a negative angle. So we're going to turn clockwise, and that's negative 263. So how far is, or how big is theta r? So theta r is where the x-axis and the terminal arm, the angle between them, that's our theta r. So theta r, how do we do that? It's going to give us negative 180 minus negative okay, so theta r, right smaller, negative 180 minus negative 270 is equals to 263. Not paying attention in here. So that's going to give us a negative 83 degrees, positive 83 degrees. Now, this topic of reference angle is actually discussed in pre-calculus, pre-calculus 11, when you were talking about this in trigonometry part. So if you want, you can review your grade 11 topic. This is a reference angle. Okay, so finding out where reference angle is. Okay, now that we have that, let's see here. Determine all angles within this domain between 0 and 360 degrees that share the same reference angle. So same reference angle. Okay, what is a reference angle again? Terminal arm and the x-axis, the angle between them. That's what the reference angle is. Angle between terminal arm and x-axis. So in this particular case, 150 degrees, it's really a good idea to draw it out. 150 would be in quadrant number 2. Okay. So theta is equals to 150 degrees. Now, what's the theta r for that? So theta r, which is this angle right there, that's 180 minus 150. So theta r is equals to 30 degrees. So we're looking for all angles that has a reference angle of 30 degrees. So where is that? Has a reference angle 30 degrees. Okay, so these ones are all angles of 30 degree, reference angle of 30 degrees. So 30 degrees, reference angle, 30 degrees, reference angle. What are those? What are the angles? What are the theta that will give us 30 degree as a reference angle? So we have a reference angle 30 degrees in quadrant 1. So in quadrant 1, theta is equals to 30 degrees. So that means in quadrant 1, the theta and reference angle are all the same thing. Now in quadrant 2, it's going to be over here. How do we figure that out? This is 30 degrees. That's turning from here to there. That's going to be 180. 180 degrees minus 30. So that's going to be 150 degrees. So from here all the way down there. What about in quadrant 3? In quadrant 3, so from here, initial arm on the positive x-axis, turning all the way here and going on to the 30 degree reference angle in the third quadrant, that's going to be 100 degrees plus 30 degrees. It's going to be 210 degrees. And then finally in quadrant number 4, okay, quadrant number 4, theta, fix it up a bit. How do we go from here all the way down there? That's going to be 360 minus 30, so 330 degrees. Okay, so all of these angles will have a reference angle of 30 degrees. Oh, I'm really like running out of room in here. So what I'm going to do is I'm going to continue on example number 4, B, C, D, and E on a separate sheet of paper so that I don't. Okay. So this is a continuation so that I don't squeeze my paper in there. So in this particular case, an example for B on page 6, we're trying to figure out all the angles that has the same reference angle. Okay, so this is the angle that's given. Okay, so where's that angle here? That angle is in, which quadrant is that? Okay, so this is the initial arm. And then we're going to turn. This is a positive angle, so we're turning positive counterclockwise. So this is 0, 90, 180, 270. I know some of you already know exactly where it's going to go. It's going to go right here in quadrant number 3. So initial arm here, and then rotates there. So that's our terminal arm. So that's 265 degrees. What is the theta r for that? What's a reference angle? So the reference angle is the angle between the positive, theta r, back again, is the angle between the terminal arm and the x-axis. So this is theta r, theta r. So what's theta r is going to be like? Well, if I take 265 and if I take away 180, I'm going to get a reference angle of 85 degrees. Okay. Well, if I have a reference angle of 85 degrees, what would be the other reference? What are the other angles that have the same reference angle? So I'll draw it out. So I can have a reference angle of 85 degrees in quadrant 1. And then I'm going to have a reference angle of 85 degrees in quadrant number 2. I'm going to have a reference angle of 85 degrees in quadrant 3, and then 85 degrees reference angle in quadrant number 4. Okay, so what is the theta? So quadrant 1. So what's the angle in that one? So that's going to be theta r is equals to 85 degrees. So theta r is equals to 85 degrees because that's from here to there. What about in quadrant number 2? Quadrant number 2 is from here all the way to this part. So what would that be? What would that be? It's going to be theta r, theta. Oops. But because we're looking for theta. So theta is going to be, if I go from here to here, that's 180. And if I take away the theta r, which is 85, so 180 minus 85, that's going to give us 95 degrees. So this is from here, initial arm, to here, that's 95 degrees. What about the angle in quadrant number 3? If we go all the way down here. So in quadrant number 3, what's a theta? It's going to be 180 plus 85 degrees. 180 plus 185 degrees, that's going to give us 265. And then quadrant number 4. Okay, so that's 265 is from here, initial arm, all the way to the terminal arm in quadrant 3. Now, what about the one in quadrant 4? From my initial arm, turning it all around to quadrant number 4. So theta is equals to 360 minus 85. degrees. So that's going to give us 360 minus 85. That's going to be 275 degrees. Okay. So all of these theta, 85 degrees, 95 degrees, 265, 275, all of these have reference angles. So 85 degrees, 95 degrees, 265, and 275 all have the same theta r, which is equals to 85 degrees. Okay, so now let's take a look at letter C. Letter C. What does letter C look like? They're giving us the angle of negative 15 degrees. Okay. What we need to do is we need to visualize where negative 15 degrees is. Now, because the angle is negative, it's going to turn clockwise. We're going to turn clockwise. So this is the angle in standard position. Okay, so that's our theta. So this is 0, this is negative 90. So negative 15 would be in quadrant 4. Oops, shouldn't be that much, but somewhere like this. This is going to be negative 15 degrees. Negative 15 degrees. Okay, so what is our theta r? It means theta r. Theta r is the angle between the x-axis and the terminal arm, and it's always positive. So theta r is equals to 15 degrees. Angle between terminal arm and x-axis. So what are the angles? What are the angles in standard position that has the same reference angle? So let's draw it out. So that means this is theta r of 15 degrees. Theta r of 15 degrees as well, right there. Okay. So what are the thetas? So theta in quadrant 1. So the reference angle and theta are the same. So theta is equals to 15 degrees. Quadrant number 2. So that's if I go from here all the way to quadrant number 2 with the reference of 15 degrees, this is going to be, what is the theta there? It's going to be 180 minus 15 degrees. 100 minus 15 degrees, this is going to be 165 degrees. In quadrant 3, what is a quadrant 3? So from here all the way down there, That's going to be 180 plus 15 degrees. So that's going to give us 195 degrees. And then finally in quadrant number 4, if we go from initial arm on the x-axis all the way around right there, that's going to be 360 minus 15 degrees, and it's going to be 345 degrees. So what does that mean? Angles 15 degrees, 165 degrees, 195 degrees, and 345 degrees all have the same theta r reference angle of 15 degrees. Okay, so that's letter C. Right, so let's now let's take a look at letter D. So letter D says here, I'm just going to write down here example 4. This is on page 6. 6 degrees. Okay, well, where is 6 degrees? 6 degrees is a positive angle, so that means we're going to rotate at in a counterclockwise motion, so 6 degrees. 6 degrees there. So that means we're going to have 6 degrees. Theta is equals to 6 degrees. So that means theta r, because it's in a positive x-axis, and in quadrant 1, theta r is also 6 degrees. So what are the angles that have a reference angle of 6 degrees? Let's just do it like this. So theta r of 6 degrees So if that's the case, now we're going to find all of the angles, all of the theta in standard position that has a reference angle of 6 degrees. So in quadrant 1, quadrant 1 is easy because whatever the theta is and then the reference angle are all the same. So theta 1, theta is equals to 6 degrees. In quadrant number 2, it's going to be how big is the angle. So from here all the way there, it's going to be 180 minus 6 degrees. That's going to be 174 degrees. In quadrant number 3, it's going to be from initial position all the way around to quadrant 3 in this terminal arm. So it's going to be 180 degrees plus 6 degrees, 186, 6 degrees. And then finally in quadrant number 4, we're going to go from initial arm all the way around to go to the quadrant number 4. So theta would be 360 minus 6 degrees is equals to 354 degrees. Okay. Oops, you can't see that. 354 degrees. So that means all angles 6 degrees, 174 degrees, 186 degrees, and 354 degrees. All of these angles in standard position have the same okay. Okay, let me finish this up first because I have some. Let me just finish this up first. So angles 6 degrees, 174, 186, and 354. All of these have the same reference angle of 6 degrees. Okay, you can see some people are, let me see. Okay, so I have some people online and asking for, please start it over in letter. Okay, so I'll start over letter D. Okay, so I'll start letter D. So this is example number 4 on page 6. So if you could start. Okay, so this is example number 4 on page 6. So it says, I'm just going to put it up in here so that you can see the question. Okay, so the question is, determine all angles between 0 and 360 degrees that share the same reference angle. So we talk about, okay, let's see, referencing. Okay, so this is 6 degrees. Now, because it's 6 degrees, that's our angle in. Okay, just because this is 60 degrees, that's our angle in our standard position. Okay, let's start over. What's a standard position? So this is angle. So the angle in standard position is the angle with the initial arm at positive x-axis and vertex at 0, 0. Okay. So starting off with this one here, so theta is the one that we actually use, the symbol that we use when we're talking about the angles. So the angle in standard position is when the initial arm is right on the positive x-axis. So this is the positive x-axis, and it's gonna rotate. It rotates counterclockwise if it's positive. So in this case, it's gonna rotate 6 degrees. So it's gonna rotate this much. So now, I think the question was, well, what's theta and what's theta r? Okay, so we talked about theta. Now we're going to talk about theta r. So theta r is, this is the angle between the terminal arm and the x-axis. Okay, so this is the terminal arm. So going back to that one. Oh my God. I'm sorry, guys. I think I'm going to do is I'm going to pause this thing